Hello, my algebras. Let's go through our solutions for our study guide today. All right, let's take a look at number 1. And when I look at this, I have to read and write from the variable's perspective, right? So I look at n is less than negative 2, or n is less than negative 2. So I know that A is the correct answer, is less than negative 2. Number 2, choose the inequality that best represents the sentence. An essay must be at least 350 words. So when I think about this, it has to be 350 words. Can it be more than that? Well, yes, it can be more than that. So I know that B is my correct answer because the essay could be more than 350 words. Now, if it said it can be no more than 350 words, then that would be C, right? All right, when I'm solving for all these equations, I want to keep in mind my PEMDAS as needed, right? And my SADMEP, and that I'm using inverse operations to solve, right? So if you're still trying to remember those things, then just write them on your test when you take it so you don't forget the next right step. Okay, number 3, I am using my inverse operation of adding 5 to both sides, getting x is greater than 18. I graph that by putting 18 in the middle, a number bigger, a number smaller, an open circle over 18, and going greater than. Open circle because it cannot be 18, but it can be more than 18. Number 4, I have to SADMEP, so I'm going to go ahead and isolate my variable by subtracting 12 to both sides and then dividing off the 3, isolating my variable, getting x is greater than negative 6. Now with this one I put negative 6 in the middle, a number bigger, which is negative 5, and a number smaller, which is negative 7. Again, an open circle because it's not equal to and it's greater than. On number 5, I have to see that I am, and if you want to use a highlighter to remind yourself, I'm going to go ahead and isolate x by dividing off a negative coefficient, right? A negative coefficient, which means I have to flip the sign. So I go ahead and divide by negative 9 on both sides, and I put w and flip the sign is greater than or equal to 3. When I graph down here, I put 3 in the middle, a number bigger, a number smaller. And this time I fill in the circle because it can be 3 or bigger than that. 3, 4, 5, and so forth. Okay, let's look at number 6. Number 6, again, I highlight with yellow because it is a negative coefficient, right? It's a negative coefficient. So I really want to make sure when I multiply or divide by a negative coefficient, I flip the sign, right? I'm going to go ahead and multiply by negative 4 on both sides because that's the inverse of division, opposite of division. And I get n is greater than or equal to negative 32. When I graph, I put negative 32 in the middle, a number smaller, a number bigger, and it could be 32 because it's equal to negative 32 or bigger than that. Number 7, I have to PEMDAS before I can SADMEP, which means I have to distribute the 2 and resolve the exponent. So 6 squared is 36, and distributing 2 times x is 2x, and 2 times 4 is 8. Now I go ahead and subtract 8 from both sides, SADMEPing using my inverse operations, and dividing off 2, getting x is less than or equal to less than or equal to 14. Put 14 in the middle, a number bigger, a number smaller, and it can be 14, so it's filled in, or less than that. Number 8, I'm going to keep solving, and they just get a little bit more interesting. These have variables on both sides. So first I have to use my inverse operations to move my 3 over here, or I could go the other way around, but this is what I chose to do. And I'm going to subtract 3 from both sides, getting rid of this 3 and canceling out this 3x. And now I have 6x is less than negative 12. I divide by 6, and I get x is less than negative 2. A negative divided by a positive is a negative. No graphing on this one. Number 9. I have to distribute first, resolve my PEMDAS before I can SADMET. So I go ahead and distribute my negative 3 to 4x, which gives me negative 12x. Negative 3 times 7 is negative 21. And now I have to get my x's on the same side. So I went ahead and used my inverse operations. Because it's negative 12x, I add 12x to both sides, getting 7x is less than or equal to negative 21. And SADMET by using my inverse operation of dividing by 7, getting x is less than or equal to negative 3. Number 12, I'm going to go ahead and distribute here. And when I distribute this 2, I see that I have a negative, I have the same amount of variable on both sides, which means this will either be a no solution or an infinite many, right? If it's false, it's no solution. And if it's true, it's infinite many solutions or all real numbers. So first, in order to find that out, we have to subtract the variables from both sides, seeing what's left over. And we get negative 10 is greater than negative 12, which is true. So I know this is infinite many solutions or all real numbers because anything can be substituted for x, or in this case p, and as long as it's a real number, and then it will always work. Always, always, always. On number 11, when I combine my like terms here, I see again I have the same value of the variable. So I subtract it to see if it's going to be infinite many or all real numbers or no solution. And I get 12 is greater than 20. Well, that's a no. It's a false statement. It is not the truth. So it is no solution because solutions are always based in truth, not in a lie. Number 12, finally getting to our part of our word problems here. The average of Paula's 2 test scores must be 90 or more for her to get at least an A in class. She got a 93 on her first one. What did she get on the second one, or what's the lowest she could get and still get an A, at least an A? So in order to do this, you have to know how to solve for an average. And an average is when you add up your total items and you divide by the number of items that you added. In this case, we have 2 tests, that's why we're dividing by 2. We know the value of the first one is 93, and the second one we're solving for that, and we have to divide by 2. Now we want to have at least an A, which is 90, but it'd be great to have more than that. So now we solve using our inverse operations, dividing off the 2 from both sides. Then we subtract 93, finding out that the second test has to be equal to or greater than 87, but the lowest it can get is 87. On 13, Jasmine and her sister are saving for an MP3 player, right? And they have these different ways they are saving their money. But bottom line, we want to know, when will Jasmine have more than her sister? So Jasmine will have more than her sister. And then we represent Jasmine with how she's saving her money. She already has $40 and she's saving $10 per week, right? Where her sister already has $60, that's why she's ahead, but she's only going to save $6 per week. And now we solve using our inverse operations, subtracting 6W from both sides and subtracting 40 for both sides, and we get in 4 weeks will be greater than $20. So we divide off the 4 and we get weeks have to be greater than 5. So we know week 6, Jasmine will have more money than her sister. Number 14 says we need to translate this verbal phrase into an inequality. So these ones are kind of different because we're not saying it's less than, we're saying the difference of 5, right? So we're saying 5 has a difference with something else, and that happens to be 4 times the number, and that's going to be greater than or equal to -7. At that point, once we've written the inequality, we go ahead and solve by subtracting 5 from both sides and dividing by -4. And when we divide by -4, right, we need to flip the sign. So we know the answer is x is less than or equal to 3. On 15, it says give 2 solutions and 2 non-solutions for each of the following inequality. So first I have to solve for that. So I subtract 5 from both sides and divide by 3, getting x is greater than 6. So solutions would be greater than 6, including 7, 8, 9, a million, whatever. And not solutions would be things that are 6 or less, right? So 6 is not a solution, has to be bigger than 6. So we could put 6 there, or 5, or 4, or so forth. 16, we need to write the what the inequality is. And the circle represents x, and it's less than that, right? It's going down from 4, right? X is less than 4. On 17, we have our first compound inequality. This is an and situation, and because it's an and situation, we know a couple of things. First of all, that it's less than, right? It also doesn't say or, so we know it's not. It means that the graph will look like this. They have to touch each other because this is an and situation, right? So I first isolate my variable by subtracting 9 from all the sides, and then dividing by 5. And I get a is greater than or equal to 1. So it's greater than or equal to 1. And a is less than 4. So it's 4. And then it's less than. But it's not filled in, right? So we want to make sure that that circle stays empty. Good. Great. 18. This is an or situation, and an or means it never touches, right? There's always this space for or in between, and we can see it's or right there because it says or. And we also see that it says great or, right? That reminds us that it's a great or. And these we always solve 2 separate inequalities, subtracting 6 from both sides, getting that x is less than -4. And then on the other side, we subtract 5 and divide by 3, getting it's also equal to or greater than 4, right? They're going opposite directions, shaded in because it could be equal to. All right, on number 19, we have another or situation. This time we just have to write it because we know it's or. We can put or in the middle and go ahead and write or, and then write our 2 inequalities. It can be less than -3, or it can be 3 or greater. On this one, it's an and situation. We know it's and, so instead we write an x to represent the center because we know x can be greater than or equal to 0 or less than 20. That little window of 0 to 19. All right, a few little more word problems for you to help you out here. These were extra parts of the study guide that I added later. So A-Day classes, you got them in your email, and B-Day classes, you got them in class today. But both have access online. I sent you all an email with it. So it's always good to print them out. Once you've done them once, do it again. Check yourself, see if you can do it. Jillian, is playing basketball in a basketball tournament and scored 24 points in her first game. Whoop whoop. And she wants to average at least 20 points for both games to receive a trophy. So we know we have to do an average. These are two things we're averaging. So we're going to add those two things, the game we don't know and the 24 points we do know, and divide by 2, right? And we want this to be at least 20 or if not more. So we go ahead and solve this by multiplying by 2 on both sides to isolate our variable, then subtract 24, and we get that she's going to need to score 16 points to get that average of 20. All right, on number 2, we have a tree that's 15 feet tall, but it's going to grow about 2 feet every year, and a telephone pole or electrical pole that's 58 feet tall. And PG&E is going to have to trim this before it hits the power line, right? We don't want to have sparks or fires, or we also don't want to lose our power. So we go ahead and set up an inequality where the pole has to be bigger than the tree, because that's when we're going to end up having to cut it down. This actually doesn't need to be an equal to, because we don't want it to be the same height. That means we're going to have a problem, right? So I go ahead and say 15 plus 2 feet, it's going to grow every year. So this must mean that this is the height side, right? And this is what we don't want it to reach, the height of the tree, and this is the height of the power line. So we go ahead and solve for this, and we get the years are 21 and a half, but we would say they want to prune in 21 years, because if they wait till 22, it will have been a problem, and you don't want to have to cut in the middle of the year in the event that, what if it grows faster that year? You're in a problem. Okay, number 3, Marcus is trying to make enough to pay his bills, right? He makes $1,500 plus 15% of his sales, and we want that to be more than his bills, which are $2,300. Once we've written the inequality and all of these, we have to write the inequality, then solve for it. We go ahead and see that we're going to subtract 1,500 from both sides, and we change this 15% into a decimal because these represent 2 decimal places, so we just move it over 2 spaces, and it's 15% is the same thing as 0.15. So then we divide off that 15%, getting us our sales are supposed to be $6,200. All right, now we are going to go to a county fair where she has purchased tickets for a t-shirt for $5, and she has $23 to spend. She wants to see how many plants she could buy. So the plants cost $2.50 each, and now we just go ahead and solve for inequality to figure out how many plants she could buy. And we find out she could buy 7.2 plants, but of course you can't buy a partial plant, so the most plants she can buy is 7 without going over spending. An important concept, how not to overspend. Okay, number 5, Rosa decides to sell pet rocks at an art fair for $5 each, and she has paid $50 to rent a table at the fair, and it costs her $2 to package each rock she sells. So in this scenario, we want our cost to be less than our make enough money for this. So we go ahead and find out that it costs $50 to rent the table, and then it costs $2 for every rock to package it, to do whatever it needs to happen, right? And we want to make sure that what we're making off of this, the sale price, is going to be more than that, and we're selling it for $5 a piece. So now we just solve, and we get, in order to make a profit, she will have to have sold 16.6 rocks, but you can't sell a partial rock in this case. So she needs to sell at least 17 rocks to make a profit. Okay, Sophia and Patton are in a typewriting contest. Sophia types 75 words a minute and Patton types 60 words a minute, but she already has 510 done. When will Sophia be able to have more written than she will? So we go ahead and write our inequalities with Sophia being 75 words a minute and Patton being 60 plus 510. And we solve using our inverse operations, subtracting the 60 minutes, getting 15. And we solve by dividing off the 15, finding out that the minutes have to be 34 at more than 34. So obviously in 35 minutes, Sophia will have typed more. Okay, Jamie. Jamie has a job paying $25,000 and expects to receive a $1,000 raise every year. But we has a job that pays $19,000 but expect a $1,500 year raise. For how long will Jamie keep the lead in making more money? So we want to know when Jamie has more, right? Has more. So we write our equation for Jamie, which is $25,000 plus $1,000 a year bonus, whereas we has 19,000 and she expects to get a $1,500 raise a year. So we go ahead and use our inverse operations, subtracting the 19,000, subtracting the 1,000, and we finally get down to the years are less than 12, right? So up until 12, Jamie's in the lead, right? So for 11 years, Jamie makes more than we. But in that 11th year, in that 12th year, that's where it all changes and we take the lead. Okay, you guys, study, practice these problems, open them up again, open up a new copy, print it, do it on your iPad, whatever it takes, but practice these. Don't forget when you come into class, your binder check needs to be ready, stapled together with this study guide, and have a great weekend. Bye.